How can we rotate axes? So what happens every now and then is that we have we have some sort of function or some sort of equation where it makes more sense to talk about it in some sort of rotated system. Um, you can think about this as if we had, instead of an ellipse that's like this, that it's rotated something along this axis, and we have that it's here. So how do we talk about an ellipse that is not, whose axes are not parallel to the coordinate grid? Well, we can talk about them in terms of rotated points, x prime and y prime. So what we're going to do today is we're going to try to figure out how can we take and convert between x prime and y prime in some sort of rotated system at x comma y. So we'll have some sort of angle here. We'll have some sort of angle here, and we know what the x prime here is and the y prime here is. How do we find out what the x coordinate and the y coordinate are? Well, first of all, let's list out what the x coordinate and y coordinate should be. The way that we measure the x prime is along this axis and perpendicular to it. So this purple piece is the x prime, this purple piece is y prime. And these are the distances parallel to the original non-rotated axes. So if we figure out how to write that, that will be x. This distance will be y. Because of the right angles, we can say that this is 90 minus theta, this is theta, this is this is 90 minus theta because of vertical angles, and then this has to be theta because those are complementary. So we have this set up. The trick to figuring this out is, first of all, of course, using trig, and to set up a additional rectangle down here. So the idea is that this is parallel to the x axis, this is parallel to the y axis, and these purple segments are parallel to the x prime, y prime axes. So we want to write the x and y coordinates of the point in terms of x prime and y prime. So let's figure out what the x coordinate is going to be. So this is x, and that's what we're looking for. The whole thing, if we look at the whole thing, this is going to be, this is a right triangle with a hypotenuse of x prime, and this is the adjacent side, so this whole length is x prime cosine of theta. But we have this additional piece right there that we want to subtract out. That piece is across from y prime, the hypotenuse is y prime, and it's across from theta, so it's y prime sine of theta. So based on this, x equals the whole thing, x prime cosine theta, minus y prime sine theta. Similarly, the whole distance from here up to there can be split into two pieces. This is y, we're looking for y, and that's this amount. That distance is the adjacent side of this triangle whose hypotenuse is y prime, so y prime cosine theta. And the other piece from here down is the opposite side of the lower triangle. So this is x prime, and it's across from it, so it's x prime sine theta. So these are our equations. In other words, to rotate x comma y by theta to x prime y prime, set x equal to x prime cosine theta minus y prime sine theta, and y set it equal to x prime sine theta plus y prime cosine theta. you can that you can think of this kind of as we have cosine, sine, cosine, and negative sine. And then here's x prime, y prime, y prime. Thanks.